This is a black hole looking a bit strange, isn't it? That's because it's not in space but present on Earth. According to an article published in Nature on March 20th, 2024, scientists have created a quantum black hole right here on Earth. You can see its image on your screen now. Surprisingly, within this black hole are all the properties present in a black hole in space, such as extreme gravitational force, an event horizon, and properties like Hawking radiation. But the biggest question is, how did scientists create this black hole on Earth? And is Earth in any danger from this quantum black hole? So, hello guys, let's start another new episode. In 1937, Soviet Union scientist Pyotr Leonidovich Kapitsa was studying the quantum properties of helium isotopes when he stumbled upon a surprising phenomenon. He observed that when helium is cooled to absolute 0 degrees Celsius, all its quantum particles reach a strange quantum state and start behaving oddly, forming a liquid form that doesn't obey any of our world's physics rules. For example, watch this video where liquid helium kept in a small container climbs up the walls of the container and falls downwards as if gravity and viscosity don't exist for it. Similarly, you can see another experiment in these photos and videos where liquid helium kept in a bottle is flowing out like a fountain on its own. Scientists named this magical behavior of quantum fluid superfluid. For scientists, all of this was almost magical at first, but gradually we realized it's not magic but science. Not just our regular science, but quantum science. Also, scientists never imagined that with the help of this superfluid, one day we might create quantum objects that mimic the properties of a black hole. We all know that our universe is full of mysteries, one of which is a mystery of black hole where all our existing theories and laws break down. The biggest reason for this is that we don't understand black holes very well. And how can we when even our closest BH1 black hole is 1,500 light-years away from Earth, and it would take millions of years for our fastest spacecraft to reach it, which is currently not even possible. So, most of what we know about black holes either comes from its radiation and radio waves traveling for thousands of light-years or is based on simulations on our computers and theories proposed by scientists. But if we really want to know about black holes, we need to experiment on them. But since we can't reach black holes in the universe, our only option is to create our own black hole right here on Earth. But was it possible until a few years ago? Now, thanks to the hard work of scientists, it has become possible, and we have found several ways to create quantum objects that mimic the properties of a black hole. Among them, during a recent experiment, we have created 2 such quantum objects that are almost identical to a black hole, and they possess almost all the properties of a black hole inside them. Until a few years ago, scientists had only 2 main methods to create quantum objects that mimic the properties of a black hole. But after recent findings, we now have a total of 3 methods in which we can create quantum black holes with similarities such as electric charge, extreme involved pull, and angular momentum. Now, let's look at the first method, the Bose-Einstein condensate. This is a quantum state in which particles are cooled significantly to almost absolute 0, where such a quantum phenomenon is created, in which all particles' wave nature, which was previously separate, begins to merge together and forms a single large wavefront. This means that in this state, all quantum particles start behaving towards a larger particle, which scientists have named optical black hole because during this merger, these quantum waves begin to slow down the light passing through them, and an event horizon-like special region is also created around the black hole, where light starts to trap in the center just like a real black hole. Now, in the second method also, to create a black hole, scientists use the Bose-Einstein condensate state, and it involves a special technique called density inversion, where the resulting quantum black holes are not made from matter but from sound waves, which scientists call sonic black hole or acoustic black hole. The idea of creating sonic black holes from sound waves was first proposed by Canadian physicist William Unruh in 1981, but due to lack of available technology at the time, it took quite some time, and finally, scientists successfully created a sonic black hole during the year 2009. In a sonic black hole, a special type of quantum freeze is quickly flowed with the speed of sound, which creates an event horizon-type region around it, trapping the surrounding sound waves inside it, and thus energy loss is also observed from its event horizon similar to real black holes. In our theories, we call it Hawking radiation. Until a few years ago, we only had sonic black holes that were similar to real black holes but did not reveal anything about real black holes, such as space-time fabric effects and gravitational effects. This means we still needed a technique to create an object that is most similar to real black holes, almost identical to those present in space. Now, black holes that exist in the fabric of space-time pose a problem. For this, we need special material that does not follow the rules of our physics like black hole. Finding the kind of material seems impossible, but scientists have found a way to do all this with the help of discovered quantum superfluid in 1960. The experiment with helium-3 and helium-4 among scientists is the most famous and super hit, but they do not exist in our world's environment. To create them, we first need to create a quantum environment, for which we need a temperature of -271 degrees Celsius, where this isotope of helium comes in liquid form. Now, if their quantum state is not disturbed, they start exhibiting many strange phenomena on their own. For example, in normal fluids, we observe many qualities such as gravity, surface tension, and friction. But when it comes to superfluids, their specialty is that none of these properties exist in them, meaning no physics rule applies to them. Now, due to the quantum properties of superfluids, theoretically, if their quantum state is never broken, they keep moving continuously without any energy loss. That is, the fountain of this superfluid will continue to fill up and fill down continuously until its quantum state is broken. In other words, superfluid is the perfect ingredient to create a black hole on Earth. Theoretically, if we could somehow spin these superfluids forever, we could create a vortex, that is, a superfluid mansion-type black hole. But this would require us to break the quantum state of the superfluid without breaking it, which is quite challenging. Recently, a team of researchers from the University of Nottingham came up with a special technique where the superfluid could be spun without breaking its quantum state. And the method involved spinning the container in which it was placed along with the entire superfluid. However, when scientists adopted this technique, initially, they didn't observe any vortex whatsoever because due to the special properties of the superfluid, it had no contact with the beaker. However, gradually, as the speed increased, there came a point in time where the critical angular velocity was so high that even in the superfluid, effects began to appear. And inside the superfluid, not a single vertex was found, but many small vortices were formed, as you are seeing now. Upon closer inspection of these small whirl vortices, scientists found that they possess properties similar to real micro-black holes in the universe. That is, until now, scientists had already created the closest object to a black hole in the lab using the help of superfluid. But here, too, there was a problem that all small vortices were quite unstable, existing only in certain states and spins. Moreover, their size was so small that studying them was quite challenging, almost impossible. Therefore, scientists quickly realized that for the study, we need actual large superfluid vortex. To create it, scientists employed the same technique as seen in the universe, where small black holes merge to form a large one. First, scientists made several attempts to merge these small vortices, and after many years of experimentation, scientists finally reached a design for a container. Now, you are looking at the picture of this device, which, when rotated at a certain frequency, creates all these small vertices in the superfluid to merge and create a large vortex black hole. This vortex black hole still measures only a few micrometers, but it is large enough for scientists to study. In their study, scientists discovered many important things about black holes. Scientists observed some extremely interesting effects inside this vortex black hole. For example, as soon as scientists merged all the small vortices to create this large vortex, a special kind of standing waves was floating throughout the superfluid. Upon studying these waves, scientists found that they bear a striking resemblance to the gravitational wave from the collision of two black holes in the universe. Additionally, another major finding we encountered was that when it was swirling, it also significantly influenced the surrounding superfluid. As we know, scientists have already claimed through their finding that black holes present in the universe also curve and stretch the space-time around them due to their strong gravitational pull. The findings in the superfluid vortex are also supporting this claim. Moreover, the most significant finding we observed here is the understanding of gravity. Scientists have seen that the pull towards the center of the vortex is only generated when it is rotating and pulling its surrounding superfluid. By relating it to particles, it is possible that these particles may not even exist, and gravity is a phenomenon that only occurs due to large systems like massive planets, stars, galaxies, and black holes creating an effect on space-time. However, I would say that our study of the vortex black hole is only in its early stages, and in this, we are getting so many things to observe. Scientists are confident that observing the superfluid vortex for a longer time will help us understand the physical and quantum state relations of black holes present in the universe better. If this happens, it will prove to be a game-changing thing because then we will be able to create a theory that merges quantum mechanics and general relativity, explaining and predicting celestial objects from the smallest quantum objects to the largest celestial objects in the universe. I think this will take a little more time, but there is no doubt that this experiment has greatly enhanced our understanding of astronomy. I hope you probably liked the video and learned a lot from it. If you did, please like the video and be sure to share it with your friends.